combustibility along with a few other properties. So we want to try to make this material easy to clean off the skin so that during an operation, if somebody were to have rubber flow into their skin, that the prognosis would be surgical excision. You'd cut it out. It could damage a fireman's skin or cave people, you know, that caught on fire, killed them, like Salem mine, or release a lot of toxins in the air. If it doesn't burn, then it doesn't release toxins. So now, moreover, if the material turns to a carboniferous particulate, means particles of carbon, it would be better to have a carbon particulate fall on a person or property so that we don't get combustion from it, and we don't get a thermal fusion in the form of a liquid plastic flowing over. It's kind of like tar or rubber, whatever, when it burns. So we want to show these properties. So we're using MAP gas here. MAP gas is rated at 5,300 degrees. This can be looked up on the internet. This is really 5,300 degrees. Now the ASTM, the ANSI, NIOSH, and the ANSI require that when they're using propane or natural gas and they test a product, they usually use it on an E285 test, the 119 open torch test, which we performed already, and we have all of that documentation on it. But we prefer oxyacetylene. However, with these lower temperature materials, these are moderately higher than normal materials, but they're not as high as some of the other materials that we make. We're using methylated acetylene stabilizing propadiene, which is MAP gas. So this will braze. This is a very high temperature material. Now, we're going to show the properties of a shingle. Everybody has shingles on their roof. We could normally show a wooden shingle, but we showed that in our first movie with balsa wood, and we got very good test results with that. This material is at 74 degrees.
75.
Okay. Now we'll test the top. 75 degrees. And the back side, which is also 75. I had my finger on that, so it must have jumped up a degree. Alright, so basically this is pretty much room temperature. It's about that right now. So now, we're going to show the thermal properties of normal tar paper that's on somebody's roof. What would happen if they were hit with a burst of methylated acetylene or MAP gas within a short period of time? So we can stay our seconds clock here, so we can figure out.
It's not. Shot right to your.
Right there?
Right there.
All right, so now we're going to see if this burns, fluxes and fuses and begins to run. Okay, we're on fire. We're starting to fuse and run. Can you see that with your camera? Okay, we're fluxing. This is not what we want in somebody's house. Neither do we want in somebody's body. This fusing and fluxing of the material into a liquid accelerant is not very good. So now we've got our compound up here that's in our exterior application. It's this color, but see, we could change this to any color we want. This is our coating that we're putting on it with our compound 2 flame out in it. Okay, I think we get the idea. Now let's see if it puts itself out. Okay, it's out. But we have no fluxing or fusing of the material. It didn't break down. it didn't continue to burn, it extinguished itself. Moreover, the backside is not melted, neither is the front. However, we had our, I said, 4 or 5 second burn on our lower shingle here. So this is a good product. This will help a lot of houses not combust into flames and burn to the ground. So we need to get this material out to the market. All right, now the next test is for, I was asked to do this test by the military. Someone sent it to me, and they asked for specific reasons to take rubber, a sample of rubber, which I went down to the Band-Aid company, and I got powdered rubber and ground up, and I put it all back together and used the same glue in each rubber, but I added my compound 2F, to flame out in both compounds. So we have rubber here, and we have rubber here. So now, two same size, same thickness as rubber. Now, the material here is very flammable. It has the same properties when it burns as the tar once it fluxes into a liquid. So we want to find out if rubber burns. We all know rubber burns. It's butadiene, and nitrobutadiene all run. They all flux fuse and run and burn in a very, very high accelerants. As a matter of fact, nitrobutadiene is what Burt Buchanan used in his spaceship to fly up into space. Nitrous oxide with butadiene rubber as a compound for rocket fuel. But this rubber here is a standard rubber. We wouldn't want it melting in a car wreck with the accelerants as gasoline and brake fluid on a person. So we're going to see how it burns and how long it takes. Okay, basically we got rubber. It's on fire. Now if we continue to let this burn, then this material will then start to fuse and flux, and it'll drop into droplets on us. Now we don't want that, so we're going to put that out. All right, so we'll put that here on our tar shingle. All right, now this is the same rubber, same batch, but this is my compound. This is compound 2 flame out. So we're going to see what results we get off of it. Okay, basically we're on fire, but oh, what happens? Look there. It put itself out. We have no fluxing and fusing, no running, no burning, and no combustion. Let's see if we can do it again. Okay, the material doesn't want to stay in a combustible state. So now, that's good. Moreover, we don't have fluxing and fusing. That means the material rubber that in a fire would flow over you, stick to your skin, kind of like this. Now see, most people wouldn't take burning rubber and put it on their hands if they knew it was going to burn them. So, we have a little rag here. We know that rubber in a fluxing, fusing state would burn right into your skin, but we also know that if rubber burned into your skin, the surgical practice is to remove it with a scalpel if it melts your skin. However, we have a different component now because the rubber won't stay on your skin. It's turned to carbon particulates, which means it turned to a different substance. That's important because we don't want to get in a car wreck and burn rubber all over, so whether we're working in a rubber factory or whatever, keep it burning.